Hi everybody, this is the third in our series of BumbleBot based MeshFusion tutorials, and in this one we're going to take a look at the accessories and some of the detailing of the head, picking up where we left off last time, which is just this basic head form. And one of the first things we're going to look at is this proboscis and this little mount for the proboscis. And the thing about this little mount is it's a technique I use often. I want to simulate the notion of a separate piece, not something that is fused, in this case, to the main head's surface, but something that might be, bolted on or glued on or whatever it is. But I definitely want it to be separate and want to see that separation between the two surfaces. So that mount will be used to connect the proboscis itself, which is this ribbed hose kind of structure, which will be a separate fusion item, yet another fusion item that we will look at in a bit. But we'll start with the mount itself, which starts out with a very simple piece of geometry. This is just one of those kind of rounded boxes, rounded box cubics that I have modified slightly to give it a little more character with this flattened side and a sharpened edge along here. I've positioned it and rotated it so that it is kind of flush and parallel to that part of the head. And but I want to actually trim it to exactly match that surface of the head. So what I did was I took the head mesh itself, or more accurately, one of the source meshes from the head, and just copied a few of its polygons, the ones that I need to trim that surface, and pasted them into a new mesh. And we will use that to make the perfect match between this mount and the head itself. And there will be a third element in this very simple fusion item we're creating for the proboscis mount, and that is a sphere that will cut a hole in it and will match a sphere on the end of the proboscis. And here is that sphere. It's just a normal cubic patch sphere, and I've already got it scaled and positioned about where I want it. And again, the idea here is that I will use a copy of that geometry in one form or another to create this proboscis itself, and that will be the base of the proboscis. And I may scale that sphere to make some gap between the two items or not. We'll see once we get there. Alright, so there we have the three meshes that will make up this simple fusion item. Hide the original head mesh there. There you go. And since this is such a simple fusion item, I'll just go with a tree-based fusion. No need to go to schematic here. I don't anticipate needing it. So we use the new fusion pop-up form. Make sure that we have our strip width and smoothing set to our low values, and tree fusion selected, and subtract others from first selected is what I'm going to use here. In anticipation of using that option, I selected the main mesh first and then selected each of the other two meshes, and that way I can use that option to make the latter two selected meshes subtractive, as we see here. Okay, so I'll go ahead and hide the tree. I don't think I'll need that for anything. And let's bring back the head fusion item that was created in the earlier videos, and we can see that we have our new piece in place. And as usual, I have neglected to name the fusion item in the new fusion pop-up, but for expediency here, I've just skipped ahead to where that's already been done, and its source meshes have already been collected using select source meshes and placed into a group locator. That's all just for convenience, and we've covered that before and we'll probably cover it again. But let's move on to the eyeballs. That will also be a separate fusion item, and it will also interact with the main head mesh. As you may recall from the previous video, we already made a copy of the eyeball meshes and used them to cut this cavity in the main head mesh. For this fusion item, what we'll be doing is adding these pins and matching notches in the eye sockets of the head. The pins are simply a radial array of 4 small cubic cylinders, and I've positioned them already so that they are ready to add to the eyeball spheres, as well as cut notches into the sockets in the main head fusion item. Since I only have these pins for one side of the head, I'll go ahead and polygon mirror the geometry so that I have pins on both sides of the head. I'm going to create two sets of these pins. Like we did with some of the earlier geometry, I want to have a separate item, a separate mesh item for the cutters that will create the matching notches in the main head. And as before, I want to use the push deform tool to make those notch cutters slightly larger than the pins themselves. So to do that, you need a separate mesh as opposed to an instance of the pins. So that's what I've done here. I have a copy of the mesh. So I have two meshes, one named iNotch and the other one I've named iPins. And let's work on those notches first. And to do that, I'll go to the schematic view. And this is the schematic for the main head mesh that we created in another video. And there you see the pins, or actually I should say the notches mesh selected, and I want to add that to this schematic. I want to subtract that mesh from the eye sockets, and since I've been lazy about naming my mesh, a simple way to find it is to select it in the item list, and there it gets highlighted in the schematic. And I'll be hooking that up to an intersection node to perform that cut. So I use the Fusion Pi menu to add a intersection node, and we'll disconnect the eye socket mesh and connect it to that intersect node. And then what we want to do is add the notch cutting mesh to the schematic, and to do that we'll use the Pi menu again with the familiar prep and add selected. And it showed up a little bit out of view there, so I just zoomed out to find it. And we'll go ahead and connect that up as a fusion feed negated to the intersection node that we just added. And that intersection node then connects back to the intersection node that was the original connection for the eye sockets. So there we have it. Notches cut into the eye socket. And as I mentioned, what I would like to do here is expand that mesh a bit so that the notches are a little bit larger than the pins that will be nested there. And I'm going to go ahead and use deform push to do that. It's a good way to do it when you have arbitrary geometry. It expands everything equally. So there are our pins. I'm going to leave them visible for reference so we can see how big of a gap we're creating. And use push deform on polygons of the notch cutting mesh. So there you can see, you can go ahead and adjust that interactively to get the kind of gap that you want, and maybe zoom in to see that it is what you want. And don't worry about the fact that in this preview mode, this draft mode, it may look a little faceted. We'll take care of that when we adjust densities of all of these meshes further down the line. Alright, so now let's create the very simple fusion item that will consist of the eyeballs and these pins that will fit nicely into those notches. For that we just need two meshes, the eyeballs themselves and the pin mesh. We'll create a new fusion item, and for once I will remember to name it before I create it. We'll just go with the tree because this is so simple. Union of meshes, and there you have it. And the tree reminds me that that pin mesh is not properly centered, so I'll use the handy center to bounds in the more fusion pop-up form to correct that. And I think we're all set there. For the most part, I want to hold off on strip adjustments until everything is in place, but in this case there's really only one set of matching strips, so I thought I would just do a quick edit of the strip settings there to get a feeling of how this all works with the notch and the pins and the gap that we created earlier. Okay, so next we're going to look at constructing the fusion item for the proboscis here, and here it is in its finished form. but we're just going to go ahead and recreate the whole thing from scratch. We'll start by creating what will be the base of the item, which is simply a duplicate of the sphere we used when creating the mount. As you recall, that fusion item, the mount, is a tree-based item, and with that there's a simple drag and drop option which brings up this menu, and we can create a non-fusion duplicate of that sphere. So gone ahead and done that, and when you do that, the duplicate shows up as a child of the original mesh item. So we see it here, and often that's what you want, so the things can be, the two items can be manipulated together. But for the sake of clarity here, I'm going to go ahead and drag that out and just put it up here so we can just use it in conjunction with the other meshes we'll use to construct the proboscis. Alright, so next we'll create the ribbed hose that makes up the main portion of the proboscis. And for that I will use a simple cylinder and an array of simple boxes, which will be joined together along with this sphere to form the fusion item. I'm going to stick with my notion of not showing much of the simple and probably somewhat clumsy traditional mesh and subdivision modeling required to set this thing up, but I thought I would just speed through the steps here so you get a general idea of bringing in a cylinder, positioning it, scaling it, that sort of stuff, and then same thing with the simple box. And in the case of the box, the only thing interesting I did there was remove some of the edge loops, since I knew the box was going to be squashed, scaled down in one direction, and also small overall, so I didn't need a lot of quads there. Removing edges like this, it's not required, but it will make for a more efficient fusion mesh. Okay, so once I have that box positioned where I want it at the base of the proboscis, I'm simply going to use duplicate clone in the polygon mode to create the ribs of this ribbed tube. Go ahead and set the number that I want, and then it can just all be done interactively by dragging in the workspace. Clearly I haven't done anything here to address the tapering that we want for this ribbed hose, and that's because that's going to be handled with deformers. It's one of the nice things about MeshFusion modeling, especially combined with deformers. You can create a kind of non-linear, non-destructive modeling setup. So here I have selected both meshes, and I am using the item menu to apply a linear fall-off deformer to those two meshes. New deformers always show up at MODO's origin, so we'll need to go to the Setup tab so that we can position this fall-off deformer relative to our geometry without affecting the geometry. And as you probably know, to do that you need to go to the Setup tab and click on the Setup button. So once you do that, you're free to transform this linear fall-off deformer without it affecting the deformed geometry. So again, trivial stuff of lining it up, and I'm just eyeballing it here. It's not that critical. Using one of the orthographic views to make that alignment a little bit clearer and easier to see. And finally, using the range slider in the properties panel for this deformer, I adjust its range, its length, so that it covers the entire hose. So in addition to tapering, I would like to be able to bend this hose. So for that, we just need to add a simple bend deformer. So we get out of Setup here, then reselect our two mesh items and go back up to the item menu and select Deformers, Apply Deformer, Bend Effector. And just like before, we need to click on the Setup button so that we can move and align this bend effector. And that involves positioning it, rotating it so that the bend goes along the long axis of the hose, and finally adjusting its length to match the length of the hose. Alright, so with all that in place, we're ready to go ahead and create a fusion item. And by the way, there's no reason that this deformer setup could not have been done after we create the fusion item. Order is not important here. In any case, I have selected the 3 meshes that I want to use for the fusion item, and it's going to be a simple union, and once again I'm just going to go with a tree-based fusion. No need to go to schematic on this one. So I'll just click on the Union of Meshes button, and there we have it. Once again, I don't really need to see the tree, so we'll just hide that. And there we have the basic form of our proboscis. Now, I normally don't mess with these things at this stage, but I see a simple thing that I would like to address right away, and that is the density of the cylinder. Because its quads were quite small, doesn't need to be that dense. Set the fusion subdivs to 1, and we get something more reasonable. And that'll help make all of this nice and interactive when we start playing with the deformers, which we can do now. So first of all, let's give this thing a little bit of a bend. That's a simple matter of selecting the bend effector and then using channel haul on its angle channel. And next we'll look at the linear fall off deformer. I'm changing it to an ease out fall off, and I can start playing with the scale to create a taper. Now of course I see right away that the fall off needs to be reversed so that I can taper it to be narrower at the tip. And I want something that's not a simple proportional taper, but rather something that becomes elliptical as it tapers towards the tip. And I've accomplished that here by applying different amounts of Y and X scaling to the linear deformer. Alright, so just to get a little bit better idea of how this is looking, I am going to go ahead and do a quick edit of the strip width, the strip between the cylinder and the boxes, just to get, again, a rough idea. So as we continue to play with it, we'll kind of know what we're getting. And looking at it, I kind of decided that I like that idea of an elliptical cross-section, and I thought I'd try to get that along the entire length. So I went ahead and went back to the original geometry, not using the deformer here, free to mix and match this stuff, and just did a disproportionate scale of the cylinder and the boxes. And of course it did not affect the sphere. I want that to remain spherical, and as usual, that's a nice aspect of fusion modeling. You can deform and distort things and still maintain the integrity of the individual mesh elements. Alright, I wanted to take a moment here and talk about some special considerations that come into effect if you want to be able to move and rotate this entire fusion item, the proboscis. As you may know, fusion items themselves do not have transforms. You transform a fusion item by transforming its source meshes. So if we take something simpler with no deformers, like the eyeballs, we can simply take the group locator that contains its meshes and move that, and thereby move the whole structure. And in fact, normally what you want to do if you plan on moving a fusion item is change that group locator to a regular locator. There are some advantages in that, including the very simple one that you can separately move the center of a regular locator by selecting it and translating it, and thereby put it in a logical position that relates to the fusion item and its source meshes. And then when you go on to move it, again by moving the locator that contains its source meshes, it all makes sense and has a center that relates to the actual geometry. But with the proboscis, since it has deformers, and especially since it has a linear fall-off deformer, I found that there are some things that you need to do differently to make all of that work properly. Now, there may be better ways, different ways to do this. Happy to hear from any MODO experts who have additional ideas, but this is a method that I have found that works. So here we have the proboscis fusion item, and below it the two effectors related to the deformers we have in play. And I'm going to go ahead and add a locator, which is what we will ultimately use to move the entire fusion item, and just give it the same name as the fusion item, and then go ahead and move all of the elements of the fusion item into that locator, make them children of that locator. So we drag on the source meshes onto the locator and drag these two effectors for our deformers onto the locator, and there it is. We see it here in the workspace, and the first thing we want to do is move its center to the location of our linear fall-off deformer. And we need to do this with the setup mode turned on. We've clicked on the setup button there, and we make sure we've selected the center, and we'll move it to that location, which is at the root, so to speak, of the linear fall-off deformer. And this is a crucial step. It needs to be done in setup mode, and that location needs to be lined up with our deformer. All right. As far as I can tell, this is kind of specific to fall-off deformers, since they essentially modify transforms. The transforms need to be properly sorted out. Now you notice things go bad once I turn setup off. And if we go into our locator here and select the linear fall off, you see that it has been transformed over here. And that's why the distortion has occurred. That's why you see the odd effect on the proboscis. And we need to get that now back to where it belongs. And that's easily accomplished by going to the linear fall-off's properties panel and doing a reset of the position. And you see it pops back into place there, and the deforms are back to normal. Now, as I said, this all seems specific to fall-off deformers. You'll notice that the bend effector, we didn't have to do anything with that. It's bending exactly as it did before. Its position is still non-zero, and all of that is fine. All right, so anyway, with all of that in place, we are now able to reposition our proboscis and rotate it, that sort of thing, using that locator, which contains all of the fusion items elements. Now, these transforms must be done with setup turned on. Otherwise, again, you would get odd distortions from that linear fall-off. But again, once you work in setup mode, you can move and rotate the fusion item, then turn setup off, and you have it back to its deformed state in the new location. So all of this together, the live fusion item, the live deformers, it really makes for a nice, non-destructive, non-linear kind of modeling setup. This is all much more than I needed here in this particular model, in this particular case, but I thought I would just show you what I've learned about setting up such things and getting them to work. This kind of setup, it's a powerful workflow, especially if you're looking to design in MODO. Gives you that freedom to really explore variants of your design. But in this case, I did not actually want to turn my bumblebee into a unicorn, so we'll just undo all those transforms and back out of setup mode here and get the proboscis back where it belongs. And in fact, there was one transform that I wanted to perform on the fusion item, and that is to rotate it about 30 degrees. So back in setup mode, rotate the locator that contains all of our fusion items to the angle that we want it, then exit setup mode, and there we have it. So we have one final head component to go, a very simple one. I've brought back the head bracket that we created in the previous video, and I have this mesh prepared for the antennae. And I'm going to go ahead and make them part of that bracket and attach them right up here. And they can be positioned wherever you like. It's kind of tight here, so I wanted to get the position where it works well with that little ridge at the top of the bracket. But once that's in place, it's a very simple matter. I'll just go to the Fusion Schematic tab and find the bracket workspace. And there we're going to want to add the antennae, so we need to prep that mesh. It's already selected, so simply use the Fusion Pi, prep and add selected meshes. There we have it. And since I don't want this affected by any of the cutters, I'm going to add it at the very end of the Fusion chain here. So to do that, we want it to be a union, so we also need to add a union node. And we can also do that with the Fusion Pi menu. There's our union node. So we take our current result, the end of everything there, hook that up to the union node, and then back to the Fusion item, and we're back to where we were. And then it's just a matter of adding the antennae as a union to the entire head bracket Fusion item, and there it is. And as I say, we'll worry about strips and densities and all that in the next video when we really wrap up the head. All right, thanks.